So the first of our invited speakers is Dr. Wayne Honeycutt of the Kentucky Honeycutts. Wayne is president and CEO of the Soil Health Institute, a nonprofit based in North Carolina that works with partners across the U.S. to safeguard and enhance the vitality and productivity of soils. He previously served for 5 years as the deputy chief for science and technology with the USDA NRCS in Washington, D.C., where he led programs involving over $250 million in annual investments to ensure that NRCS conservation practices reflect the latest scientific advances for conserving our nation's soil, water, air, plant, and energy resources. Earlier, he worked as a soil scientist for 24 years with the USDA ARS New England Plant, Soil, and Water Laboratory. The last 10 of those years serving as the research leader of that organization, where he led and conducted interdisciplinary research on carbon, nitrogen, and phosphorus cycling and sustainable cropping systems development. I had a chance yesterday to get acquainted a bit with Wayne and his work, and I believe you'll enjoy hearing more from him about the efforts and progress with soil health in the U.S. Let's welcome Wayne to the podium.
Thank you very much.
Thanks for being here.
Thank you very much. My pleasure. Good morning, everyone. Well, for those of you that were adding up all the years as he was going through with them, I just want to let you know that the case could really be made that the 5 years in D.C. should really be measured in dog years. And so it's really, I've really kind of been working for about 75 to 80 when you add it all up. I want to tell you it's really a pleasure to be with you all today, and for so many reasons, but particularly I hope that so many of you in Mizzou know what treasures you have here. The treasures you have with the Soil Health Assessment Center, the treasures that you have with the Agroforestry Center. I mean, these are actually national, if not international treasures. Not every place has them. And so I just hope that you all really appreciate it and kind of make the most of that while you're here, particularly the students. Make the most of that, the connections that the faculty and the staff here has nationally and internationally while you're here. I was asked to visit with you on some of the priorities for advancing soil health management systems. And I'll tell you that I'm a bit guilty of doing that through the lens of what we feel like are those priorities with the Soil Health Institute. But I'll describe a little bit later that we've had pretty tremendous involvement of the stakeholder community to help us identify those priorities. But I want to caveat kind of the list of priorities, the things that I discuss, with that disclaimer that you know, we do not feel like that we have the market on all good ideas. In fact, we're sure we do not. But these are some of the priorities that have kind of bubbled up to us, and so I wanted to share those with you. So to kind of help frame this, just kind of a quick assessment of the current situation. You all know this. You've probably already seen this. You know that just in the next, 32 years, we're going to have another 2 billion mouths to feed in the U.S. And I'm sorry, in the world. But we also know that we're losing arable farmland at an alarming rate. So our ability to do it is really becoming more and more constrained. Here's another reality. This is looking at a graph from 4 very reputable organizations like NASA, NOAA, Japanese Meteorological Society, showing what the temperature changes have been from 1880. Particularly since 1980, we've seen a significant increase in temperature. In fact, the highest temperatures in the last 2 or 3 decades that's ever been recorded. In fact, you can go much, much further than this, using like ice core data, tree ring data, coral reef data, that shows that the temperatures we're seeing now worldwide in the last 10, 20 years are the warmest for over the last 1,000 years. So just think for a minute. I mean, there's so many interactions, but just think of one little process. Just think of evaporation. Okay, so with higher temperature, greater evaporation, now, okay, so well, we need to feed more people, so we need to grow more plants, we need to grow more beef, et cetera. All right, so now what's that going to do to our need to irrigate? So we're going to probably need to irrigate more. Well, now what's that going to do to salmon habitat? I mean, all these things are interconnected. This is the loss of Arctic ice since that 1980 period. It's now currently about half of the size it was just in 1980. I didn't make these data up. This is from NASA, pretty reputable. If climate change is not real, then why is the ice melting? We also know that when temperatures increase, that warmer air holds more moisture. And so what that can lead to is not only can you have sure periods of drought like we've been experiencing, but then when it does rain, it can rain like crazy. So again, it's from about 1980, 1990, this is the increase in the number of extreme one-day precipitation events. So it can rain harder and harder. So now we have to think about how we're going to protect our soil more and more for those more extreme weather events. And of course, the farmers that are trying to produce this food for this burgeoning population, this is another extreme challenge that they have. Predictions are by the middle of this century, from that 30-year period from 2036 to 2065, there will be a minimum of an additional 18 drought months for major portions of the United States. And this is just with modest amounts of greenhouse gas emissions. We also know that increasingly the spotlight is being focused towards our farmers and reducing the phosphorus, nitrogen, sediment, those types of things that are showing up in our waterways, like the Western Lake Erie Basin, Chesapeake Bay, the Gulf of Mexico hypoxic zone. This was a report on our nation's rivers and streams, their assessment by EPA, saying some 78% of our nation's rivers and streams are in only fair to poor biological condition. We also know that many of our soils are losing organic matter, is most accurately measured by organic carbon. They've been losing them ever since we started tilling them. Now, there's a lot of data here. Just look at different years, different soils, looking at soil organic carbon, the best way you measure it, again, organic matter, and the uncultivated versus cultivated. These are different articles that have been published in the peer-reviewed scientific literature. So, all of these reasons are what really kind of brought us to forming the Soil Health Institute. It started from the Samuel Roberts Noble Foundation in Oklahoma, which had been in existence since like 1945, and the Farm Foundation, which has been in existence in 1933. They created something back in 2013 called the Soil Renaissance. It was really trying to kind of reawaken, kind of the world to the importance of soil and all these issues that I just showed you here and how we can address them with soil. And they lined this up as like a 3-year project, and they realized about 2 years into it that this ain't no 3-year project, that this is something that requires a much longer term commitment. And so the Noble Foundation received a 10-year, $20 million commitment to stand up the Soil Health Institute. And so that's how we got our genesis. And so our mission is to safeguard and enhance the vitality and productivity of soils through scientific research and advancement. So yes, sure, part of it's research, but when we say advancement, we're also looking at how we can partner with organizations, individuals, to really extend that adoption of those practices and systems. Now, I wanted to give you just kind of a little background on the roles of the Institute because I hope you will see yourself in there as a potential partner. So the value that we try to add is really to identify what some of those gaps are in the research and the adoption, and then to build those strategies, those partnerships, those networks that can address those. And then I'm not bashful about it, and then go out and get funding for it. I don't feel like we have, I guess, things are too pressing for us right now with all the issues that I just laid out to just kind of relax. I feel like I have to be aggressive at trying to get funding for it. But the point is that the funding that comes in for us, it's not for us because we have our funding from that foundation that stood us up. So what we can do now is get that funding out for addressing these issues. And so we do that through an accountable, transparent, proficient grants program. But then we also, in those grants that we award, we ensure that there's a line to ensuring that there's the impact. Like if it's research, we want to see a direct site to that adoption. So looking at incorporating those results in educational materials and tech transfer. This is quick on the draw. It's got a hair trigger, I've just learned. Yeah. Much like a 38 special I inherited. Yeah. So I mentioned the stakeholder input. Through that soil renaissance effort, there was some 3 years of input where, I don't know, it's probably like 6, 8 separate workshops. Over 500 stakeholders are engaged from across the country to identify what they saw, some of the gaps and some of the priorities. And so while my disclaimer is that a lot of these gaps and priorities that we see for the Institute and that we are offering for the greater soil health community, yeah, they're coming from us, but we feel like that so many of them would apply and be applicable for you too. And so with that stakeholder input, we developed an action plan. And we made a distinction between kind of a strategic plan, which are very useful, but they're generally kind of high cut, you know, kind of overall goals. We really wanted to get down to the specifics about what are the specific gaps and what are the specific actionable steps to address those gaps. And so this is not a quick read. It's many pages long, but it was not meant to be a quick read. It was meant to be a very specific document that we and others could use as a guideline for advancing soil health. We released it at a National Press Club event just this last May. Had a number of folks there, like a 6th-generation farmer, representing National Corn Growers Association, acting chief of NRCS, Natural Resource Conservation Service, vice president and chief sustainability for General Mills, and the director of Working Lands globally for the Nature Conservancy. And so I'm going to go through some of those priorities that we see for advancing soil health. So one of our kind of overall pillars is in the research area. And one of the overall goals in that area is enhancing productivity and resilience. Of course, there's a lot of different ways that we can do this. This is just kind of one example. Looking at this relationship here between soil organic carbon and water holding content. You can see these lines here not parallel. Available water holding capacity increases when you increase the organic carbon content in your soil. By our estimations, and it depends on your assumptions of bulk density for all you soil scientists in the room, you know, I acknowledge that. It depends on certain assumptions you make. But by our estimations and calculations, when you increase organic carbon by 1%, you increase the ability of the soils to hold water, plant available water, by anywhere from 2,500 to 12,000 gallons per acre in the top 6 inches alone. Now, I'm always quick to point out to farmers and ranchers that this does not make it rain. But what it does do is it helps their soil and their plants and their animals, including us that are feeding on those plants, make the most of every raindrop that it receives. And the same is true for irrigated systems. Help them be more efficient, you know, with their application and how many times they need to apply. So in the research area, this is just one of those relationships. These relationships are different for different soils. Is that one of our priorities is to take this kind of relationship that we know that we can build resilience to things like drought that we know is coming, to things like increased temperature that we know is coming, the extreme weather events that we know is coming, and take this type of information, understand these relationships, quantify them, develop the equations or the algorithms, and then develop decision support tools for farmers and ranchers. So now in the comfort of their keyboard, their own home, now they can change, you know, alternative rotations and cover crops and different mixes in terms of their ability to enhance their organic carbon, so then they can essentially design their system to achieve a targeted level of increase in water holding capacity, and therefore a targeted level of resilience to things like drought. And so that's just kind of an example of one of the things, you know, that we see as just a tremendous opportunity for soil health. And you'll see, you know, a little bit later that so many of these soil health practices are also really beneficial for the environment, for water quality too. So it's one of those rare win-win situations where by focusing and helping the farmers adopt these practices, all the public and the environment will also benefit. Well, it is quick on the draw. Another kind of related opportunity that we see is the impact of soil health and these practices on infiltration. Again, we're going to be having heavy precipitation. So is it going to run off or is it going to go into the soil and therefore recharge the soil so it's there for when the plants need it? So different studies in the literature, different periods of time, different tillage and cropping systems. Look at the impact on infiltration. That one study at the top, when they added a cover crop, they got a 182% increase in the infiltration rate. The next one, it ranged from 164 to 462, 132 to 194, 165. So then, obviously our research question is, why is this so variable? How can we best understand this to achieve those changes in the soil properties to optimize this infiltration? And then how can then we take that information, again, put it into decision support tools so that farmers can develop their production system, their practices, tillage, rotation, lack of tillage, rotation, manure additions, these types of things, to increase things like aggregate stability, you know, how the individual sand, silt, and clay particles bind together to optimize their infiltration rate. And this is not just an academic exercise. When you're out in nature, in the real world, out of the laboratory, and you're in the right place at the right time, you can see the results of these things. Here on the left, in a no-till system, the soybean, and on the right, it's obviously a tilled system. You can see there's no water ponded on the left, but that there is on the right. And so what happens, of course, is that raindrops, when they hit those soil aggregates, then it breaks them apart. So now those individual sand, silt, and clay particles settle out. And so now they can kind of become a crust and a barrier. And so what's happening is the field on the right, they're really kind of missing some of that opportunity to recharge that soil with moisture. But also to the extent that now it runs off, then, then it becomes more of a societal impact, right, of nutrients in our waterways and soil in our waterways. I should also tell you that I received a photograph from a friend at NRCS. I was neither brave enough nor tall enough to straddle a barbed wire fence. One of the another areas that we see in the research, and I'm thinking of one of your ARS collaborators that you have here, you're fortunate to have here, University of Missouri, Kristen Wiem, that's in the back here. She's going to be speaking a little bit later today too, is this idea of building disease suppressive soils. And that really kind of gets to a fundamental understanding of those microbial communities in soil and what functions they play in terms of nutrient availability, but also disease suppression, you know, to help naturally suppress some soil-borne diseases. But then how you can now nurture those specific species and communities of microorganisms. And you know, there's a lot of really good interest in cover crops, but I feel like that we are just really kind of touching the surface there, because one of the values of cover crops is, yeah, building organic matter and, you know, intercepting water flow and stuff, but it's also keeping that living root that's growing throughout the year. And at times when the soil often would be bare if it weren't for the cover crops, like in the fall, winter, and spring, keeping that living root there so that those microbial communities are also fed, you know, by those root exudates. And so I feel like that we're not far off, but this is the type of opportunity that we see with developing those types of cover crops that will be the right species to help promote the right species of microorganisms to then, you know, achieve that natural disease suppression. So one of the research priorities that we see. Another one of kind of the big goals is quantifying and enhancing environmental and human health benefits. There's work that we want to do with improving water quality by enhancing nutrient use efficiency. This nutrient use efficiency is often kind of described as one number. you know, just the amount of recovery by the plant in relationship to the amount that you put on. Well, the reality is that, think about it, plants need different amounts of nutrients at different stages of growth. Early on, they don't need very much. As they grow more rapidly, they need more. And then when they go from that vegetative stage or that reproductive stage, like the ears on the corn, for example, then they start to need a different amount. And there's also a changing availability as organic matter decomposes in the soil. So you have, it's not just one number. There's a dynamic relationship there between the plant needs and the availability of those nutrients. So it's really, I feel like understanding and developing those relationships of that dynamic nutrient use efficiency, and then again, developing things like decision support tools that will accommodate that, and that can basically be in real time, because it's like temperature and moisture driven, to help improve that nutrient use efficiency. And by doing so, reducing those losses to our waterways. Here's another one of those benefits that I mentioned of things like cover crops and benefits to the environment. Again, a lot of different studies in the peer-reviewed literature, different cover crops. You can see the reductions in nitrate leaching. So that's nitrate that now is not getting into our groundwater because these cover crops have reduced nitrate leaching. In that one study, 65 to 70%, 30%, 63, 61. There was a recent study, not so recent, I think it was 2010. And I can't remember exactly, it's like some 30 or 40 or something like that studies where they kind of conducted a meta-analysis of all these different studies looking at cover crop impacts on leaching, and they determined that on average, cover crops reduce nitrate leaching by some 70%. Increasing carbon sequestration in reducing greenhouse gas emissions. Carbon sequestration is one of those things you often hear a lot about, but what you often don't hear and recognize is that different soils have different capacities, you know, to sequester carbon and to maintain it. It depends on a lot of things, like your sand, silt, and clay content, but it also, there's an equilibrium that has to be, you know, developed in your climatic zone with your carbon inputs. And so it's just not quite as easy as sometimes you hear it mentioned. And but that's one of the things that we want to do in our priorities is help quantify the capacity for carbon sequestration throughout all the soils of the U.S. So then we can better match those up with those practices and know what is achievable, and then work to achieve the achievable in each of those situations. And I guess I just wanted to point out too that it's very clear, because we're more active, it seems like, you know, in managing cropland, but a lot of these principles and practices can be applied, you know, for grazing lands. The way that, you know, you manage your animals influences what goes on below the ground. The way that you manage the biomass above ground influences the biomass below ground. And a third way of saying that's the way that you manage your carbon above ground influences the carbon below ground. And this is really quick. I should just set it down or have somebody else to push it for me. This is kind of an example of the darker soil on the right. There's these are the same soil series, but they've been managed differently. This is in South Dakota, continuous grazing versus the rotational grazing. So the soil on the right that was rotationally grazed, they've used processes there where they are just, you know, not continually removing the carbon, but they're letting it grow back. And they're influencing, therefore, the root activity and the carbon that the roots provide in the soil. So that darker soil, of course, from the organic matter, the organic carbon, so that soil is going to have a higher water holding capacity. It's going to be more resilient to things like drought. And then that would be shown, you know, in the sustainability of that entire operation. One of the opportunities and priorities that we see is really exciting to us, and we feel like because we know so little about it, is the opportunities we have for relating soil health to human health. Yeah, there are a number of aspects when it comes down to kind of the overall human health, but just kind of one particular example is thinking about now if we increase organic matter, now roots, you know, we're increasing nutrient availability, we're increasing a plant's ability to, you know, have a greater root mass, and to basically exploit the soil for nutrients and water. So doesn't it make sense that we can influence the nutrient density of the food that we eat and then our animals eat? We are in the process now, we have a steering committee that's going to be having a small conference, probably just 150 or so this fall, to really kind of outline the gaps in this area. And with this conference, we're not just inviting a bunch of soil scientists. We're gonna try to get dietitians, MDs, folks like that there, so that we can really try to do that kind of cross-pollination that needs to occur to identify those gaps. This is one of those areas in our action plan where we're not saying, here are the specific things you need to do research-wise. Our specificity there is, we need to gather all these people. We need to find out what these gaps are, because we feel like it's largely untapped. There's been some efforts, but largely untapped. Another real effort and priority that we see is in the measurements area. And so we're looking at trying to determine the right appropriate measurements, design pilot studies addressing those, and eventually we want to conduct a full soil health assessment. Now, I want to spend a little time on this one because this is really kind of one of those key things. You know, people, they want to know, well, what does soil health mean? How are we going to measure it? And so we feel like that what we really need is kind of a national approach. And so here's what I would say is kind of a situation analysis. There's a number of real chemical, physical measurements that are really well established, been using them from decades, things like nitrogen, phosphorus, pH, right? Soil's chemical, physical, biological. We have a lot of the chemical, worked out. Not so much the biological measurements. There's a number of them that are really, coming out now, but so many of them haven't been really well evaluated. They may be evaluated in one region, not another, and sometimes we know, well, that number's bigger than that, but we don't know what, how much is good. And so there's a lot of that type of work that needs to be done. Some of the promising evaluation programs exist, but they kind of need, we feel, further testing and scaling up. Some of the quantitative analyses relating to other drivers of adoption, like economics and ecosystem services, need to occur. A lot of these variations in soils and climate production system, they really kind of hindered the development of more of a national approach. And so we feel like that to address a lot of these issues, we really need to be strategic and develop a nationally coordinated approach for this. And so we have recently been benefits of some funding that's going to allow us to address this. And our approach is, when you think of all these different agricultural experiments and sites that have the appropriate replicated design, that are just all across the country, we feel like that those are just ripe for providing the information for addressing this. And so just kind of give you just a brief example. This is just the soil, a map of this dominant soil orders. And then, but ARS, USDA ARS has these long-term agroecosystem research sites all across the country, some 18 or so and growing. So there are those sites we could tap into. There's also National Science Foundation has funded these long-term ecological research sites. So there's those sites that could be sampled and tapped into. Then there's the NEON network, National Ecological Observatory Network. There's ARS's GraceNet, Greenhouse Gas Reduction through Agricultural Carbon Enhancement Project, some 33 sites across the U.S. And now, this is really interesting because it now would not only allow us to say how well do these soil health measures do at distinguishing differences in soils, but now let's just take that next step and say, how does this relate to greenhouse gas emissions? So now we're into the world of thinking, how does this relate to some of these ecosystem services, and really kind of bring forth the value of soil health to those, quantifying those ecosystem services. Same with water quality. Conservation Effects Assessment Project, where they have all these instrumented watersheds and subwatersheds that, again, we can sample those for soil health and seeing how well these different measurements do at distinguishing different soil impacts and practices, but then relate those values to water quality. Critical Zone Observatory, you get the idea. And so putting all those together, this is just the beginning of the universe of opportunity. because I'm sure all of you all realized, hopefully you're not offended yet, but what's not on here are all the university sites, the land-grant university research sites. Sanborn Field is not on here yet. I mean, there's such a huge opportunity, and so that's basically our approach right now, is that we will soon be submitting releasing some requests for applications for long-term sites where we're just basically going to be asking for a minimal amount of information of these and basically curate them in a database, develop a GIS of them. So then we can basically kind of create virtual networks and go out and sample them one time and work with those individual site managers and scientists to help us analyze all these different soil health metrics. We have started that directory. Rob Myers helped us out quite a bit on that, and this funding for this project has come from General Mills and Foundation for Food and Agriculture Research. Economics is another big area for us. One of them, of course, is quantifying economic risk. For example, if we increase water holding capacity, then shouldn't we build resilience and greater yield stability? And so we're kind of trying to finish up a project on that, but we feel like that this next one here, profitability, is really key, and that's what farmers focus on, but we feel like that some of these soil health practices also could be really beneficial for reducing the economic risk. And then there's the whole approaches to establishing monetization of soil health. That gets to what's the value of clean water? What is the land value now different? If one particular piece of land has been farmed a certain way that now is more productive, that's more resilient, shouldn't that be reflected in the land valuation? And so there are aspects of this that some of them are not easy, like quantifying the monetary value for clean water, and subject to assumptions in many probably PhD theses, but we feel like that this is one of those things that need to be addressed. Communications, education is kind of one of those big kind of priority areas for us. Some of this is a little bit self-serving in terms of strengthening our online presence, but it's just so that we can be a better communicator of information that we bring in and to distribute it. Looking at developing a lot of collaborations with universities, other scientific organizations for developing educational materials, distributing those materials. And so that's not just for farmers, but for like the ag retailers, the consultants that work directly with farmers, but then also the general public. We feel like there's a real need there too. So am I about to get the hook?
Oh, no, you got
Oh, okay, all right.
Sorry.
I'm getting close. And so that's recorded in it. So now we have that in for perpetuity there. And then one other area that we are focusing on is policy. And it's basically wanting to make sure that our policies are well informed. And so there's some activities that we have going on there with taking an assessment of current policies and evaluating them for whether or not they are positive for soil health or detrimental to soil health. For those that could be potentially detrimental, that at a minimum we want to neutralize them. And if not, turn them around and make them to be positive and beneficial for soil health. And so we have a number of different volunteers, action teams that are working with us on all of these areas, on the policy, the communications, the research, et cetera. And what we are sure to do is to ask for volunteer help on these action teams working on all these things, ask their help on items that don't require money until we get money in. And then when we get the funding in, then we can start to fund more of them. And so some of them is just asking for their ideas and how this should look, how it should be planned. But we have some like 24 different action teams, some 130 volunteers around the country now. And so a way to kind of get engaged in that, if this interests you, is to go to the website. How many talks have you heard with go to our website? But if you could go there, there's a place to check a box on what you're interested in and different types of action team activities to get engaged. Again, I guess I can't reiterate enough the point that as self-serving as that sounds, it's really not, because we are meant to serve you all. We are meant to serve the public and the farmers, because again, the funding that we bring in, we get almost every penny of it back out the door for addressing these issues. And so I guess I would just close by saying that I'm of the opinion that enhancing the health of not only our nation's soils, but our world's soils is one of the most important endeavors of our lifetime. And I really believe this, just to help prepare the earth for those next generations. And I personally believe it becomes more incumbent upon us to do this with every single day that passes, that greenhouse gases are emitted, that the world population grows, that we lose wildlife and pollinator and other wildlife habitat, that farmers are faced with these extreme weather events. And so we feel like that it's just extremely imperative that we enhance the health of our nation's and our world soils. So again, I appreciate very much the opportunity to come visit with you all today, and thank you very much for your attention.
We do have some time for question
Oh,
and answers.
okay.
So we have about 10 minutes, so we're ahead of schedule. So please, if there's any questions or...
If I'd realized that, I would have spoken longer. Yeah. Yes, sir.
Much of what you're talking about, it seems like it should be priorities of the land-grant universities and extension. And what's your analysis of that? That are they not moving fast enough? Could the national research grants be reprioritized to make this happen faster?
Yeah, and your question, I think, is partly one of the reasons why I wanted to emphasize kind of the roles of the Institute, because there have been folks I visited with at land grants where they thought maybe we're competing and we're trying to duplicate efforts, and I guarantee you it's not that at all, and hopefully that message has gotten across. I guess I would not say that there's any kind of a criticism for what land grants and other organizations are doing or not doing, but we are trying to be kind of that value added component to kind of bring resources into this area to help stimulate more of these investments that we see as needed. And so again, it's not that it's not an evaluation or a critique of anything falling short. It's that we're just seeing that all these challenges that I laid out, they're real. And the impact that they're going to have just in the next few years and decades is going to impact us, our children, our grandchildren, our wildlife, our water quality, all these things. And so we feel like the time is now. And so we're just doing the best that we can to try to bring in those additional resources to get these issues addressed. That help? When it'd be somebody in the very back row.
What's your take on the future of getting some of these soil health tests in producers' hands, and how, once they're in producers' hands, how do you suggest they connect the dots between whatever their soil health test tells them and maybe a nitrogen recommendation for corn? Or how can they apply that test directly to some in-season or management practices that they have with corn or soybeans or whatever crop they may be growing?
Yeah, and so I think that's a really critical question, because again, we are not doing any of this as an academic exercise. We do feel like that, although it may appear kind of academic for looking at developing these virtual networks and sampling them, that's our end goal, is to really be able to develop soil health measurement evaluation programs that can be interpreted within the context of a farmer's constraints, climatic, region where they are, the production system that they are in. And so it's not an easy task, or it would have already happened, but that's why we're kind of jumping off into that. But that is our ultimate goal. So I do think that we'll get there. I think that there are some more kind of state and regional efforts that are already showing a lot of benefit, a lot of efforts. The Soil Health Assessment Center right here on campus is one of those cases in point. they've identified a number of those key soil health metrics, and they're using those to help farmers and guide their management decisions already. And so our approach is also wanting to take good ideas like that and seeing if we can scale them up, essentially, on more of a national perspective. Any others? The distinguished Peter Scarf. Do you all know Peter?
Hello.
Good.
Wayne.
Where we're here,
Sorry, I called on Peter first, then her.
where we're sitting, we've lost about half of our topsoil in the last 150 years. And, so my concern, I'd love to build our soil quality up, but, it's been going down so rapidly. And you had that slide near the beginning showing loss of organic matter. And Chris talked about how we spent, I don't know, $10 million a year in some recent years, or maybe you did. Someone was saying that. That's about $1 an acre of cropland. What I see is what you're doing is trying to ramp up, and I think we really need to ramp up. Do you think we can ramp up fast enough to save what we have and not lose it in the next 100 years?
I guess I'm the eternal optimist, and so I have to think yes, but yeah, it's going to take all boots on the ground effort. I mean, that's kind of a role that we're trying to help play, but recognizing, like for the question in the back regarding what's it mean to the farmer, there has to be that clear line of sight to how that information, those activities are going to be directly beneficial to them. Now, kind of I think your other part of your question too is regarding erosion. For us, again, our mission is to safeguard and enhance vitality, and so the safeguard addresses. We got to curb erosion and stop erosion first, and then we get really start building. But yeah, we can't just keep washing away what we're trying to build year by year. We got to get on that net positive gain. I realize that is challenging, but I also think that the benefits to improving soil health can really kind of be the ultimate motivator for farmers. Sure, there are really benefits to having like these financial assistance programs and things like that where they can help be paid for adopting these practices, can really help them along that learning curve. But I feel like that if we can develop things like the decision support tools that as a risk manager, where they can see that they can build up carbon in their soil, curb erosion through these practices, build up the organic matter in their soil, as a way of being a risk manager to increase their water holding capacity, and avert negative drought impacts, then that can be kind of the ultimate driver for expanded adoption. And so that's why we're really kind of taking a full focus on all these different things with the research that's needed, but also with the policy efforts and all these things that are all interconnected. Thank you.
Wayne, I have a question. This is not from it's definitely from the soil health point of view. My question is about the measurements. I know your institute has recommended phase 1, a group of tests that you are recommending, and then you have come up with this phase 2, lots of tests too. So I've been involved a little bit on that one, and North American Proficiency Testing Program, I'm one of the committee members, and we are evaluating some of these criteria which are more important and we feel comfortable about recommending to be tested. So in my question to you is, when you came with that big list of phase 1 group of tests and the phase 2, you're pushing them as recommended. So I want to know whether you plan to do some research to support these methods that can be related to crop response, nutrient response, and things like that.
Yeah, and so perhaps I was not clear in describing it, but the virtual networks where the different sites maybe have conducted, like no tillage versus moldboard plow, or with or without cover crops, or rotation and without rotation. And a lot of these long-term sites were set up to address those types of questions, when the reality is they can be reframed to also ask the question, is how does this soil health promoting practice compare with like some type of control or soil health non-promoting practice? And so we are looking at sampling all those to evaluate their relative changes in productivity, things like yield and economics. I use the word relative because I'm the first to recognize that an experiment station yield is different from a farm yield, and with different plot sizes and all those types of things that influence that yield. But that is basically our approach, is to evaluate all these different metrics, and we've got well over 20 of them, kind of what we described as the 19 Tier 1 measurements that a number of organizations have kind of got behind as what we feel like when we say Tier 1, that they are ready for use. But we want to evaluate them on all these different sites, but then also go to the Tier 2 and Tier 3 measurements, which are categories that they're not quite ready for prime time. For example, some may have been developed in one region but not evaluated in the other regions, or one system but not other systems. And so we want to then evaluate them also. And so there will be plenty of opportunity for us to scratch our head, I'm sure, when it comes down to how we best make those interpretations that is then going to be useful for the farmer too. So that basically is our approach. And we have actually been engaging with organizations that you mentioned. I don't know if you've been on any of those calls or not, kind of those standard measurement proficiency type of organizations to kind of get their reaction to this. And some of it is, it's a little bit like sticking your toe in the water, and then that's when you find out whether or not there's any sharks swimming in it. And because sometimes there's a little bit of territory there that you're stepping out on. Well, I'll put it this way: when I was with USDA, I had to worry about that a little bit more. Now I don't have to worry about it as much. Now I'm just trying to push this baby as much as we can and seeing how far we can get. You all had enough? Great. Thank you all very much.